We're just swimming in data every single day, right? It's on your phone, it's in the news, it's all over your job. It feels like this constant flood of information. So the big question is, how do you make sense of it all without getting totally swept away? How do we learn to actually read the stories that all this data is trying to tell us? Well, that's exactly what we're here to figure out.
I mean, you see charts like this all the time, showing us the price of gas has been on a total roller coaster for decades. Or maybe you see something telling you the price of a movie ticket just keeps going up and up and up. It really feels like we're constantly being hit with numbers and graphs telling us something. But here's the catch, and it's a big one. These visuals, these charts and graphs, they can be used to show you the facts, plain and simple. Or they can be used to mislead you, to actually distort the truth. And in this explainer, we're going to give you the tools to spot the difference. Okay, first things first. We need the right equipment for the job. So we're going to build a visual toolkit that'll help us understand the basic language data speaks. Our very first tool is the bar graph. I want you to think of it like a lineup. It's perfect for comparing different groups side by side to see, which one's taller, which one's shorter, who's the winner. And here is a fantastic, if slightly weird, example. This chart compares a few record-setting collections. You can see it instantly, right? The biggest collection is, wait for it, 3,300 airplane sickness bags. It's a bit crazy, for sure, but it's a super memorable way to see a bar chart doing its job perfectly. So the bottom line is really simple. If you ever need to compare different things, different products, different groups of people, a bar chart is going to be your best friend. All right, let's grab our next tool. This is the line graph. So if a bar graph is a lineup, then a line graph, well, that's a journey. It connects the dots and shows you how something has changed over time. Just look at the story of cell phone adoption in the US. This isn't just a list of numbers for each year, it's a dramatic story of explosive growth. You can literally see the trend, that incredible takeoff right there in the steep curve of the line. And that's all there is to it. Whenever you want to see a story unfold over minutes, days, or even decades, a line graph is the tool for the job. It's all about tracking those trends. Our final tool is the scatterplot. Now, this one's for all the detectives out there. A scatterplot basically just throws a bunch of dots on a graph to help you see if two totally different things might actually be related to each other. So, take a look at the weights of giant pumpkins over a handful of years. Each one of those dots is a prize-winning pumpkin. Do you see a pattern? The dots kind of seem to be moving up and to the right, don't they? That suggests there's a relationship here. As the years went on, the winning pumpkins got heavier. And that really gets to its main purpose. Whenever you find yourself asking, I wonder if these two things are connected, a scatterplot is exactly where you should start your investigation. Okay, so now we've got the tools, but a toolkit is only really useful if you've got a good method for using it. So it's time to stop just looking at graphs and start thinking like a statistician. See, according to the Gase report, which is a major framework for teaching this stuff, statistics is way more than just crunching numbers. It's really a problem-solving process that always, and I mean always, depends on context to find the real meaning. And that whole process boils down to 4 key steps. First, you have to ask a clear question. Then, you go out and collect the right data. Third, you analyze that data using the tools we just talked about. And finally, and this is the most important part, you interpret what it all means in the real world. Question, collect, analyze, interpret. That's the mantra. So, now that we're armed with our toolkit and our 4-step method, we're ready for the final boss, spotting the traps. Let's take a look at how data can be presented in some really devious, misleading ways. All right, have a look at this bar chart comparing ice cream prices. Now, at a quick glance, it looks like Dag and Hawes cost twice as much as Ted and Jimmy's. I mean, the bar is double the height. But look closer. Look at that vertical axis, the y-axis. It doesn't start at 0. It starts at $2. And that is a classic trick. By messing with the scale, the graph creates this visual impression of a massive difference, when in reality, it's just 50 cents. It's a total distortion of the truth, and it's designed to fool your eye. So, rule number 1, always check the axes. Okay, here's the next big trap. Let's say you make a scatter plot and you find a really clear pattern, a clear relationship between two things. Does that automatically mean you found the cause? For example, This scatter plot seems to show that as the number of fast food meals people eat goes up, their body weight also tends to go up. It looks like a pretty clear positive relationship, right? But then, what about this one? This one plots fast food meals against test scores. The dots are just all over the place. There's no clear pattern here at all, no relationship. Just because two things might seem connected doesn't mean they actually are. And this brings us to what might be the single most important rule in all of statistics. Correlation does not equal causation. A scatter plot can show you that two things are related. That's correlation. But it can never, ever prove that one thing causes the other. Proving that is a much, much tougher case to make. So, we have covered a ton of ground here. The tools, the method, and the traps to avoid. And what you've gained is more than just a little bit of knowledge. It's kind of like a new superpower for navigating the modern world. Here's your checklist. First, always ask yourself, what story is this data trying to tell me? Second, inspect those axes like you're a detective on a case. Third, let's say it together, correlation is not causation. And finally, always question the context. Where did these numbers come from, and why were they even collected in the first place?
And why does all this matter so much? Well, because sometimes the stakes are incredibly high. As the GSA report reminds us, the Space Shuttle Challenger disaster was, at its heart, partly a failure to properly analyze and present data. Understanding this stuff isn't just some academic exercise. It can have literal life or death consequences.
So, from here on out, you're not just a passive observer anymore. You are now a critical thinker, an interpreter of data. The next time a chart or a graph flashes in front of you, you'll know what to do. The only question left is, what's the first thing you're going to look